Okay, then we can start. So yeah, basically, I think we all know that AI was a very hot topic in the tech industry for the last, I don't know, five years, and it still is a hot topic today. But what about AI in DevOps? What does it mean? How can we use it, and why is it important? So, in short, what's the problem I'm trying to solve here? Well, to start with, let's look at the traditional DevOps lifecycle as we know it. We know DevOps is a set of practices which typically combines software development, so the dev part, and IT operations managing the software, so the operations part, to sort of shorten the system's development lifecycle and maybe provide continuous delivery with a high software quality standard. Now, the DevOps lifecycle typically includes phases like planning, coding, building the application, testing it, releasing and deploying it, as well as operating and monitoring how it behaves, where each phase is typically very important for the success of the general software development process, and it requires steady collaboration between development and operation teams. So again, what's the problem we are trying to solve with AI in DevOps? Well, let's take, for example, we have a manual or error-prone process, as we can't really tell or say that everyone is on the same track with DevOps processes. So traditional DevOps often relies heavily on sort of manual interventions, which could lead to inefficiencies because repetitive tasks can consume unnecessary time and decrease the likelihood of human error, which in the end not only slows down operations, but also results in inefficient use of infrastructure resources. Next up, we might face the issue of delayed issue detection or response, because without any real-time data processing or monitoring, teams can often struggle to detect and react maybe to issues in a quick manner, which can result in longer downtimes and hinder the ability to handle some critical incidents efficiently, which can lead to a poor user experience. Also, collaboration between the development and operations team can be hindered by some differences in technical expertise, which can make it difficult to maintain some, consistent efficiency and productivity across different teams, which can again lead to communication and skill gaps or misunderstandings. But then there are sort of scalability issues, because as DevOps teams try to scale their operations in dynamic environments, they often face the challenge due to a lack of automation or maybe even AI-driven processes, which could ease these burdens of steady growth of the application, which can again hinder the ability to keep up with an increasing demand for the application. We should also consider some security vulnerabilities, because the absence of real-time threat detection or automated defenses can increase the risk of cyber attacks or data breaches or any other security incidents. Which could leave businesses exposed to significant risks and again can result in severe consequences for the organization or even the users. And lastly, we might face the challenge of adapting to any rapid changes we have in today's fast-evolving digital landscape, because businesses which fail to adopt advanced or maybe even AI-driven solutions are at the risk of falling behind competitors. And we know the inability to innovate quickly not only can sort of hinder growth, but it also affects the capacity to meet any changing demands. So how can AI step in and solve these challenges in DevOps for us? Well, first of all, AI can assist developers and operation teams in making faster, data-driven decisions by providing insights or recommendations based on real-time data, which is crucial in an environment where insights at the right time can significantly impact the project outcomes. And tools such as coding assistants like GitHub Copilot or AI-powered code review and testing tools could potentially enhance the productivity of teams by reducing the actual manual workload and allowing team members to focus on higher value tasks. Moreover, AI can also help in bridging the gaps in the DevOps lifecycle as it strengthens the improved collaboration between, let's say, development, testing, or operations by automating some routine tasks and generating insights or summarizations that can create or facilitate better decision-making across any team. Also, with AI tools, organizations can pretty much predict potential issues within their IT infrastructure, which enables sort of predictive maintenance for them, which allows them to sort of optimize resources and prevent downtime, which ultimately improves the performance of the system. Now, AI also plays an important role in achieving faster software delivery in general, as in the DevOps context, AI-driven tools could potentially streamline workflows, automate testing processes, and again, optimize deployment processes, which not only leads to a faster software delivery cycle, but it also enhances the overall quality of the software being delivered. And finally, of course, AI can help organizations to manage and sort of enforce their governance or compliance requirements in a more efficient manner. For example, by automating risk assessments, monitoring, and of course, reporting processes. With all that, AI can ensure that organizations can maintain their compliance while, again, reducing the manual burden of teams. Now, luckily, there are plenty of tools and platforms available which can help us integrate AI into our DevOps processes. Yeah, you can think of a tool for every step in our DevOps lifecycle, from, let's say, planning and coding with Atlassian AI or GitHub Copilot, of course, to testing with FirstMate, deployment with, for example, Harness or Kubia, and monitoring with Dynatrace or, of course, Big Panda. If you haven't already, you can check out our webinar on AI tools in DevOps processes or life cycles for more information on these specific tools and how they can improve the DevOps process. Now, in this workshop, we will go a little bit deeper into the core of AI concepts, which are particularly interesting or impactful in software development. So what I'm trying to achieve with you is that we sort of accompany the process of using some tools and frameworks, and so we can build our own AI applications and understand the concepts behind them and how we can integrate them in our infrastructure. So let's start from the beginning and look at the core concepts of AI. I know by now everyone has already come across AI somewhere. We know AI is a very, very broad field, and it can be used in virtually any different way. But in our context, I think it wouldn't hurt to understand certain terms or concepts to simply get a better understanding of the technology we're actually using. So let's start from the bottom. What does AI mean? Well, AI, which is of course short for artificial intelligence, is about simulating or sort of mimicking human intelligence processes, which is typically done by machines or modern computer systems as we know them today. Now, these intelligence processes typically include things like learning, reasoning, and of course, self-correction. We know again that AI is a broad field which includes a wide range of different applications from, let's say, chatbots and virtual assistants to even self-driving cars or medical diagnosis systems. And as many different use cases for AI developed really fast, and we typically want AI to do more and more complex tasks, the field of AI has, evolved quickly, and we can sort of categorize it into 3 different subfields, which I would like to show you very quickly. Yeah, as I've said, AI can typically be divided into 3 bigger categories based on their capabilities and their scope, which can help us to understand where we are today and what the future might hold. So first of all, we have narrow AI, which is what we use most today. It's designed to perform a specific task, like recognizing faces or recommending movies, beating me at chess, for example, or simply answering questions. So in general, it's highly specialized, but it can't go beyond its programmed purpose. Now, the next step in this evolution would be general AI, which until today pretty much remains theoretical, but with the latest advancements with all sorts of AI models or agents, we are already scratching the surface of it. Because this type of AI would have the ability to perform any intellectual tasks like a human can do, with reasoning, learning, and of course the adaptability across a wide range of tasks and not only 1 or 2. And finally, there would be the super AI, which again, until today is a hypothetical future where AI can somehow surpass human intelligence in every field, including creativity, problem solving, and even emotional understanding, and maybe develop independence, which sounds exciting, but it also raises very important ethical and safety concerns. But enough of that. Let's now go even deeper and talk about machine learning, which is one of the core components of artificial intelligence. Now, machine learning, or short ML, refers to the use of certain program algorithms which allow systems to learn from data and improve their performance over time without being explicitly programmed. So essentially, it's just about teaching machines to make predictions or decisions based on certain patterns within the data. And typically, there are 3 main types of machine learning. First of all, we have supervised learning, where the model is trained on labeled known data, meaning that the input comes with the correct output, which is, for example, commonly used for tasks like classification. Now we have unsupervised learning as well, where the model works with unlabeled or unknown data to just find hidden patterns or groupings within the data or reduce the dimensions of the data. And then we have reinforcement learning, where the model itself learns by interacting with a virtual environment and receiving feedback in form of rewards or penalties. And finally, machine learning also includes deep learning, which is a special method because it uses neural networks within multiple layers of interconnected nodes to process more complex data and learn in a, how do I put it, hierarchical manner of representations within the data. So this is pretty much the foundations for many of the advanced AI applications like image recognition or natural language processing, which we need. So as already introduced, deep learning is just a special subset of machine learning because deep learning sort of mimics the structure or the functioning of our human brain by using, like I told you, neural networks with multiple layers of nodes, which are all connected to each other. And these layers process the data in a hierarchical manner, meaning that they are learning simple features in the initial layers and then get progressively more complex in the deeper or later layers. And this approach pretty much allows deep learning models to be exceptionally good at tasks like image recognition or natural language processing, or even speech recognition. For example, a convolutional neural network is extremely effective for analyzing images, while, for example, a recurrent neural network is designed for sequential data like texts or time series. So deep learning is a key driver behind many of our advanced AI applications we see today. And it's what powers technologies like self-driving cars, virtual assistants, or even large language models we're discussing in this very workshop. However, when building machine learning models, it's not just about creating the model itself and we are done. It's equally important to think about how we train and test it to ensure that it performs well in real-world scenarios. So the process typically starts with the data input, where we gather and prepare the data so the model can learn from it. Otherwise, the model won't be able to do anything useful with it. So this data is then typically split into a training data, which the model can use to learn and identify patterns. And then we have the testing data, which basically evaluates how well the model reacts to new unseen data. So yeah, another very important aspect would be the hyperparameter tuning, where we adjust some small minor settings like the learning rate or the number of layers to optimize the model's performance, which can have a huge impact. And alongside this, the data processing at the beginning ensures that the data we use is clean, normalized, and ready for the model to process effectively. But even with a well-trained or well-prepared model, we need to watch out for issues like overfitting, where the model becomes too tailored to the training data and it struggles with new inputs, or on the other hand, underfitting, where we have the complete opposite, where it fails to capture any underlying patterns within the data itself. So ultimately, the goal is to find or achieve a model which can generalize well for new unseen data, where the model can perform consistently across any input. So yeah, what do I want to bring to you? With this, I basically just want to clarify that building anything with AI is not just a one-time job, but It's more of like a process that needs to be repeated and refined over time. So if we manage these steps carefully, we can create models which are not only accurate, but also reliable and robust in real-world applications. And yeah, that's pretty much already happening exceptionally well today because AI is literally everywhere and evolving so fast, it's hard to imagine to use anything, any use case without it. So I've already mentioned that, yeah, AI is used in almost every field because it enables us to interact with technology, for example, hands-free, whether it's in our cars, homes, or even in our pockets. Now, recommendations, for example, for movies, music, or products are also powered by AI algorithms. And even our social media feeds are personalized by AI. So it can generate photorealistic images while write articles or even compose whole songs. We can also chat with it, ask it questions, and get answers instantly. And of course, there are robots. And I don't mean just the ones that entertain us by dancing or the, cheap toys, but also those which really assist in hospitals, factories, and even in our homes, like the Tesla Optimus, which Elon Musk wants to bring to our homes now. And yeah, some AI applications really have become so effective and just so deeply integrated into our lives that we almost take them for granted. But one subset of AI use case has really gained particularly significant attention in the recent years, which is generative AI. Now, generative AI is a subset of artificial intelligence that, well, as the name already suggests, focuses on generating new content such as texts, images, or even audio. So it can create this new data, which was originally trained on its large knowledge base of some existing data, often using large language models, which we will dive into them in a moment, to generate human-like content. So as you might think, generative AI also has a wide range of applications from language understanding, creative writing, or even content generation to image synthesis, and even music composition. So why is this important? Well, as generative AI can analyze and generate new content based on human understanding, it can be used to automate tasks which would typically require human-like creativity or understanding, such as, again, writing articles or whatever, generating code snippets, or simply helping us with tasks which would require our human thinking. And this brings me now to my next important topic, which would be about large language models, or again, for short, LLMs. Now, large language models are pretty much at the core of generative AI because they enable human-like text processing and generation, which is also called natural language processing. But how does this actually work? Well, large language models are trained on really big, massive data sets of texts to understand and generate human language like we know it. It learns patterns, structures, and relationships within the data, and they can then use these patterns to predict words, phrases, or even entire paragraphs in a given context. And it can also analyze large amount of texts, so it can understand fine nuances or certain structures like the tone or the style of the text or the language, which enables the large language models to adapt to responses based on a given context. And as of the current state, they are already capable of processing and generating complex texts with a very good high accuracy and efficiency, which makes them a very good choice for a wide range of applications from, again, chatbots or content generation to even question answering and translation. So, but how can we imagine this? Well, let's say we, the user, we input a query or a sentence or a question, any form of input into the LLM, which is called the prompt. The large language model then processes the input we give it token by token, which could be a single character or an entire word, and generates a response based on the input and the data it was trained on. And this response is then returned to the user, which essentially is just a sequence of generated tokens with the highest probability of them being the correct response. So if we think about it, LLMs are only sort of assigning probabilities to sequences of tokens, and on that building a sequence, which means that these models don't really think or understand like we humans do, but they rather predict the most likely sequence of tokens based on the data they were trained on. Now, okay, as already teased on the training of AI slides, we know that even large language models feature a lot of parameters which define their capabilities and their behavior. For example, the temperature controls how creative or focused the model's responses should be. A higher temperature would lead to a more diverse or creative output, while a lower one keeps things precise. Now, embedding vectors are another key parameter because they simply represent the meaning of words and help the model to sort of understand the relationships between them. Then we have the size of the model, which is often measured in billions of parameters, and it determines how complex and powerful the model can be. For example, larger models can handle more advanced or complex tasks, but they will typically require more resources. We also have quantization, which pretty much just reduces the model's size and can make it faster to run, especially on hardware-limited devices. So in short, these parameters like temperature, embedding, and so on, they shape how a large language model can perform, and it allows us to fine-tune it for any specific tasks. So we've already heard some examples of how large language models can be used. So let's maybe quickly recap some of the most common applications. First of all, there's language and text understanding, of course. As mentioned earlier, AI can perform natural language processing, which means that it can provide highly accurate, for example, translations across any language, and it can also simplify or manipulate large volumes of information, like articles or research papers, which makes them easier to understand or simply work with. Next, we also have the text-based content generation, because LLMs are, of course, also capable of writing new creative content like technical documents or reports or whatever. And it's not just limited to human languages only, because it can also generate code for us to automate various programming tasks. Then we also have media understanding and creation, because by using additional models like any diffusion model such as DALL-E or Sora, AI can also generate multimedia content, including images, videos, or even entire songs. And finally, we have question answering, of course, because with AI-powered chatbots, we can efficiently handle any sort of inquiry, such as a customer service question, and of course, receive domain-specific knowledge, but we will get into that later. So I think now is a good time to look at how we can run our own large language models, either locally or in the cloud. And by that, I don't mean we just go to ChatGPT and start chatting. I think as a developer, we might want to look behind the covers. And for this, I want to highlight two tools which can help us to run large language models. First of all, or one would be OpenAI, the OpenAI platform, and then we'll use Ollama. Now, of course, for OpenAI, we will interact with ChatGPT, but we will also look at the OpenAI Playground platform and the API, and how we can use it in our applications. Again, we want to see a bit more. I'm sorry if you see this flickering. It's gone now. All right. But first of all, let's take a look at OpenAI, which is one of the, of course, most well-known providers of large language models today. Now, OpenAI offers a range of its own models, of course, including GPT 3.5 or GPT 4.0, and I think by now even O1, and yeah, many more, which can be accessed through their own cloud-based platform. And we can interact with these models through the OpenAI Playground, which I will show you in a bit, which provides a simple and user-friendly interface for simply testing and experimenting with all of these models. And additionally, OpenAI also offers an API access for integrating their models into your own applications, allowing us to build our own chatbots, content generations, or any other AI-powered application. And this platform typically operates on the pay-as-you-go model, so it makes it scalable and easy to use for an application's needs. The dashboard is pretty straightforward. I just wanted to show you the different usage aspects, how often you used and interacted with a model, or how much it did cost you. I just wanted to show you the API keys tab, where you can manage or create your API keys to access the actual models from your application. And down here, we have the Open API Cookbook, which includes some interesting and cool tutorials and best practices to create your own application. But again, the more interesting part would be the playground, where we can simply test our interactions with the different models. So if we simply start with the simple chat feature, we can already see we have a lot more control than we have on the user side ChatGPT. So of course I can just type in anything like, hello, who are you? And I can run it. And of course I can expect that the assistant or the model would answer in a way I expect. However, if we look up here, we already have something interesting, which is called the system message instruction. Because here we can just type in how I want the model to behave. For example, I can type in, you are Dumbo for the cool and hip freestyler who always, I don't know, starts at the end of sentence. And with that, the model is saved. And if I were to ask again, hello, where are you? Then I can expect the model to answer in a very fun and unique way. Exactly. So, and if you look closely at the bottom right here, we can see how long it took the model to generate a response and how many tokens we have used. So how many input tokens and how many output tokens we used for this last interaction. Now, if we look at the upper right here, we can see a chat history, which pretty much only shows us the interactions we recently had with the model. And I can also go ahead and simply compare different models and look how they would behave. And what's also very cool is this little code tab here, because because it pretty much completes us which type of model we want to have, and I can just go ahead and copy it and use it within my own application. I have every dependency set up. All right, then what did I want to show you exactly? And on the right side, we can finally see the different fine-tuned hyperparameters for a model. Now, of course, I can select any different model which I want to use. And I can also say, yes, please answer in text, or simply answer as a JSON object. So if I write hello JSON, for example, it would put out the answer in a JSON object. And now here in my model configuration, I could also change the temperature, which again sort of determines the variety of the output. So let's, for example, set that down to 0.3, and I ask it, what is AI? Okay, it's interesting. That's very cool. What are you doing? Okay, that didn't work. What is AI? Okay, that's unexpected, because I would have expected it to simply use a few words to exactly describe me what AI is. Because the other way around, if I would set it to 1.6, for example, and write what is AI, again, please don't let me down. And it does whatever it wants to. That's great. Yeah, I don't want to waste any more time on this. I'm very sorry it didn't work, but I just wanted to show you, if we set the slider all up and I would ask the same again, because then something interesting would have happened, because I was just telling the model to use its sort of imagination as it wants, and there are no constraints. This way, the model output would have been some way nonsensical. Just try it one more time. Okay, now it works, and we can see what happens, because yeah, it's very interesting, because with a temperature set too high, the model just doesn't know when to stop, and it just creates anything it wants, or it has up its generation pipeline. Then with max tokens, we could determine how long we want the output to be. So if I set that to 20 and I just type, I don't know, who is John Travolta? Oh, that didn't work. But you can see what it does, because it just generates a sentence up to 20 tokens, and then it just completely interrupts its process. Yeah, that's pretty much what I wanted to show you here, because OpenAI also offers some more services to use, which are not particularly interesting for us right now. And honestly, I don't want to waste any more time on that. So let's just go back to the slides. All right, yeah, that's pretty much what I just wanted to show you. We can interact with the chat model, or maybe we can also use the real-time feature, which would basically start a real-time conversation based on the spoken language. Now the question is, we saw the cloud-hosted model option, But what if we want to run large language models on our own infrastructure, our own personal machines, for example, to maybe have more control over the models or simply to ensure data privacy or security implications? Well, turns out we actually can. And for this, I would like to introduce Ollama, which is a tool that allows us to run large language models locally on our own machines. So, as I've just mentioned, with Ollama, we can run large language models locally on our own devices or our own server infrastructure. And because as it runs locally, it provides a very flexible and secure environment for running these models with a local API endpoint, which can be accessed by your applications, for example. It's also very easy to set up and use, and it supports various models from Mixtral or, of course, Llama. And yeah, we can also configure it the way we want. It also offers a Docker compatibility, which makes it easier for us to deploy and manage these models in, let's say, a containerized environment. So let's now have a look at Ollama and see what we can do. But before I switch screens again, I just want to show you how this would work. So to get started with Ollama, we can, of course, download this tool from their own website and install it on our own machine. We could also install it with Brew, and currently it's available for macOS, Linux, and of course, Windows. And yeah, this is where it gets interesting because as billions of parameters require a lot of computational power, running LLMs locally has some hard requirements to run it efficiently. And for Ollama, in this case, the minimum setup, we should have at least 4 CPU cores and of course 8 gigabytes of RAM. However, this whole memory requirement will vary based on the size of the models which we would use. Additionally, a GPU support can also speed up processing times, especially for large language models or complexer tasks. So to run an LLM with Ollama, you can open up a terminal and install a model using the Ollama pull command, which will download a certain model which you've specified and its dependencies to your machine. And there are plenty of models available, like I said, each with their different sizes, versions, and capabilities. And once the model is installed, we can simply start the large language model with the Ollama run command, where we can simply specify the model we want to run. This will start the model and provide us with a local API endpoint, which we can also use to interact with the model. So, yes, and just like we saw with OpenAI, Ollama also allows us to customize all of these models we run to suit our specific needs. And this thing can be done by creating a model file, which simply defines the model's parameters, the system prompts, for example, or other settings. And by fine-tuning this model, we can control its behavior and optimize its performance for any different task or application. And this is, for example, what a model file could look like. Here we're just using the standard Llama 2 model. We're setting the temperature hyperparameter to 1.5 to give me a bit more creative responses. And we're defining a custom system prompt. And this time, again, I'm instructing it to be Professor Dumbledore from Hogwarts, and he's providing guidance about Hogwarts and wizardry. And when I've compiled the model file, model creates a sort of copy of the standard model with the specified settings, which can then be used to run the model. First of all, what you will notice is that Ollama doesn't really have a user interface like we would expect it to. Because Ollama is just a service which runs on your machine in the background, so if we wanted to interact with a local model, we would use I'm sorry, we would have to use any command line interface. So with Ollama list, like we saw, I can simply list the models I have. And of course, I forgot to start the Ollama list app. Yeah, with Ollama list, as you can see, I already have many models on my machine. And I think I will just use the latest Llama 2 version. And for this, I will just type Llama run Llama double L Llama 2. And we can see it loads the model in the memory and we're good to go. So I can just start typing. If it were to finish loading. Yes, just write hello. And yeah, that's the thing. As you can already see, this all runs a little bit slower, which in this case is due to my hardware, which again is an important factor to consider because running these large language models locally does require some beefy hardware. And of course, that always depends on the volume of the model. So with Control D, I can just exit this model instance, and let me also show you what the model file looks like. Oops. Okay. It does seem my computer does not want to work with me anymore. I'm so sorry, but you've already seen the model file, my custom model file within my slides. And luckily, I've already created this model, so I can just type Ollama run Hogwarts because I compiled my model as Hogwarts. So if I write, hello, who are you again? And you can see as it types, my machine gets louder and louder. I hope you don't mind or hear it. Yeah, maybe we can see it pretty much behaves as we expect it to. New student at Hogwarts, adjust spectacles, welcome my dear, and so on and so on. I don't want to torture my MacBook any longer. And we could also use Ollama in our own applications, as I've explained earlier. So we could run Ollama as a service using the Ollama serve command, which will start the specified or as the default defined model and provide a local API endpoint, which we can then use to send our requests to or from my applications. Now, let's move on to some practical interaction strategies for large language models to get the most out of these models. And this would be prompt engineering. You might have already heard of it. It's simply like being the puppeteer of an AI, where we carefully craft the strings which would control how the model responds. So in general, it's the process of designing and refining prompts, the input to, like I said, effectively interact with the large language models. So the goal in the end is to optimize the model's output by creating prompts which are clear, specific, and of course, relevant to the context I give it. Because a well-crafted prompt can enhance the model's performance, leading to a more accurate and useful response. Because with prompt engineering, I would also reduce misunderstandings, because by giving it precise instructions again, I can minimize any sorts of misunderstandings and guide the model towards the desired outcome, which is especially important for complex tasks where structured and detailed prompts can help the model to tackle any complex query step by step. So the first prompting techniques, if you want to call it like that, would be zero-shot prompting. And it's pretty much the most basic technique where we have no examples to the model provided. Instead, the prompt just gives direct instructions to the model itself, relying on its own pre-trained model knowledge to generate the response. And this approach might be useful for simple tasks where the model can rely on its own existing understanding of any data to provide accurate answers. However, it might not always be as effective for more complex tasks, which would typically require additional context or examples. This is where few-shot prompting comes in, because few-shot prompting, as the name suggests, is a step up from zero-shot prompting, where a few examples are sort of provided in the prompt to help the model understand the task patterns. So I give the model a few examples so it can learn the structure and the context of the task, improving its overall performance on this specific task, for example, by translating languages. Now, this technique is especially useful for tasks which would require a bit more context or examples to generate accurate responses. Then we have chain of thought prompting, which encourages step-by-step reasoning. So basically, we are breaking down a complex task into smaller, more manageable subtasks by guiding the model through a structured thought process, so we can improve its accuracy on complex tasks, such as math or logical problems. And we also have role prompting, which basically assigns a specific role to a large language model, so we can guide it to frame responses in a particular context the way we want. So by instructing the model to take on a specific role, we can ensure that its responses are tailored to that role's knowledge, expertise, or maybe tone, which is especially useful for tasks which would require specialized knowledge or a specific perspective, maybe, such as explaining any complex foreign concept or providing expert advice. Now, there are, of course, many more prompting techniques which can be used to optimize the model's performance for any specific task. For example, we have task decomposition, which will break down the complex tasks again into smaller, more manageable subtasks, like we heard in the chain of thought process. And there will also be constraint generation limits, which basically limits the model's output to a specific parameter or constraint, which ensures that the model's responses are relevant or coherent. And tree of thoughts would guide the model through a structured thought process to reach any conclusion in which would improve its accuracy on logical or simply reasoning tasks. So we see that we can do very much with large language models and prompt engineering. But there is one important use case I mentioned earlier, which was about retrieving domain-specific knowledge. But how can we do that? Because we know that LLMs are typically trained on general data up to a certain point of time, like a year. So it's hard to work with specific or up-to-date or even domain or company information. And this is where retrieval augmented generation, or short RAG, comes into play, which is another important topic for our AI applications. So let's talk about RAG. Now, RAG can be seen as a sort of framework which combines the content understanding and the generation capabilities of large language models with their external knowledge retrieval method, which allows it to produce more accurate and context-aware responses, which makes it ideal for specialized domain applications where we need up-to-date or any specific information. So how can we imagine this? Well, let's look at this image for a second. So imagine you have a chatbot which would answer questions about your product. And when a user asks their question, the chatbot then sends this prompt to the RAG model instance. The RAG model then retrieves relevant information from your product documentation or maybe the company knowledge base, and it injects it into the model, which generates this very response based on this information. So in short, RAG is a very powerful way to combine the strengths of large language models with external knowledge. So by combining all of this content understanding and generation with information retrieval methods, it can produce more accurate, context-aware responses, which makes it a very good choice for any specialized domain applications. And it also helps us to reduce hallucinations, which are incorrect or irrelevant responses generated by the model. And yeah, by integrating all of this, like I said, information retrieval with the language generation, it can enhance the quality and the relevance of the content generated by the model, which would improve the overall user experience. So now I think we have a good understanding of how all of these core concepts of AI work and how we can run large language models on our own machines, hopefully.